So I'm Paul Beckwith. I have an engineering physics degree, and I also have a master's degree in physics and laser optics. And I followed the climate change issue very carefully over the years, and decided that there was nothing else as important as going in and studying it and further informally at the university. So I started in the master's program at University of Ottawa a couple of years ago, and I got so interested in studying it that I switched to the PhD program, which I'm now doing. My thesis topic is abrupt climate change, so I'm looking at very rapid climate changes in the paleo records to see what happened millions of years ago, how quickly things change, and I'm trying to find out what's going on today, because I've had this gut feeling that things are just not right. Things are changing too fast. So I was hoping to actually do the PhD and look at all the tipping points or all the weak points of the system and see what tipping point would be reached first. And at the time, 2 years ago, I thought, okay, it could be the Amazon rainforest. They had a massive drought in 2005 and 2010, which killed many trees. Water's recycled there, so if you don't get rain going in, the whole thing goes under drought. And also the other thing was obviously the sea ice. So I expected to be able to finish the PhD before things happen, but that's not the case. So I think I'm quite sure my research is showing, I think we're going through an abrupt climate change transition right now. The sea ice is the first tipping point. So you have this white parasol on top of the world, and it reflects a lot of the incoming solar radiation, so it keeps the Arctic cool. So what's happening is, with the massive sea ice destruction, and I'll talk about what's caused that in a minute, but with that massive destruction, the warming is greatly accelerated in the Arctic, greatly accelerated. Like if you go up high Arctic, it's 4 or 5 times faster than the global change in global temperature average. So what that is doing is it's decreasing the temperature difference between the equator and the pole, because the equator doesn't change that much. If you're on the equator, the temperature might vary 3 degrees year-round from winter to summer, not much change. You get 12 hours of dark, 12 hours of light. When you go to the pole, it used to be a lot colder there, and now it's a lot warmer, so the temperature difference has decreased. So what that does is that slows down the jet streams. The jet streams are high-altitude winds that are traveling about 10 kilometers up on average. And they basically guide storms. So they're slowing down, and when they slow down, because of some physical properties, instead of going from west to east with very small waves, they're much more meridional, they're much wavier. So the waves can actually travel completely down to, like 1,500 miles, or 1,500 kilometers, 2,000 kilometers, those can be the wave amplitude. So not only are the winds moving slowly, it's guiding the storms much more slowly, but because it's warmer in general, like for every 1 degree rise in global temperature, you get 7% more water vapor in the atmosphere. We're up about 0.6 degrees in the last 30 years, so we have 4% more moisture in the atmosphere than we did 30 years ago. So what this means is this moisture carries energy. The energy from the sun comes in, heats the water, that water evaporates, that water carries latent heat up into the atmosphere, and when it condenses into clouds, it fuels massive storms. So the storms are not only moving slower, so staying in one area longer and not reaching other areas, causing droughts in other areas, but they're carrying more water vapor overall. So they're moving slower and they're carrying more water vapor. So we're seeing places flooded out. It's just that, places get flooded out. This changes things around the world. It's also interesting because even in the southern hemisphere, we're seeing shifts. Like there's this belt called the Intertropical Convergence Zone, where the winds come together and the moisture rises and you get loads of rain. And those things can feed monsoons and things, and those things are shifting. They're shifting latitude. In India this year, the monsoon was 2 months late, and it was very weak when it came. This is, about 800 million people or something require that rain for the monsoon. 80% of India's rain is from the monsoon season. We're also seeing stressed boreal forests. We're getting the pine beetle, we're getting the emerald ash borer. These things are, the forests are getting weak from the climate change, from the weather change that's hitting them. So they're open to dying off from the pine beetle, which isn't killed in the winters like it used to be, emerald ash borer. So we got the Amazon rainforest as a tipping point under stress. We've got the boreal forests. Greenland, of course, the melt rates on Greenland are significantly increasing. Now, in terms of this is just the beginning. This is not a fluke. So, the ice, we lost tremendous amounts of sea ice this year. We had a massive cyclone go through from August 2nd to August 10th, and it basically churned up the ice. It was a very large storm, and it broke up the ice into small particles, and it ported the ice out into the Atlantic where it quickly melted. But not only that, when you have a low pressure area like a storm, it sucks up the water. So the water in the Arctic, over almost the entire Arctic, it rose up a foot. So in order to make up for that displaced water, you had massive influx of warm water from both the Bering Strait and also from the Atlantic. So that's warmer water. Also, ocean buoys that were measuring the temperature profile down in the water detected vertical movement of water 500 meters down. So while that cyclone was churning up the ice and on the surface, it was mixing the fresh water from the melted ice with warmer, saltier water from below, as far as 500 meters below, and that also contributed to the melting. So in that 1 week, we lost about 0.8 million square kilometers of ice, which is in perspective, that's 23.5% of the amount of ice that we had left in the previous minimum melt, which was 2007. So I mean, this stuff is going, and as more and more that goes, the models. Okay, forget about the 2100. I mean, you hear this 2100 and 2100. This will happen. That'll happen. Okay, it's happening now. It's happening now on a very fast time scale. So basically, throw away the models that say sea ice will be gone in 2040 to 2070 or 2030 to 2070. I went to a talk recently with the glaciologist guy, and he's putting up a graph saying 2030, 2050, the ice is gone. So I made a big scene. I just about fell out of my chair. I said, this is ridiculous. Look at the data. Look at the recent data, because what the data is showing, if you look at the sea ice volume, which is important, not the area, it's the volume. So the volume is dropping off a cliff, basically. And if you just fit an exponential curve to the data, it shows that there's a 50% chance there will be no sea ice in September by 2015. That number is greater than 5% in 2013. It's greater than 95% in 2018. So, okay, so it's going to be gone. Okay, let's say it's gone in 2015. That was for a month in September. The data also, the model also shows that within a year or two of that first disappearance, it's gone for 3 months of the year in the Arctic. Within about 4 or 5 years, it's gone for 6 or 7 months of the year. And within about 8 or 9 years, it's gone year-round. Now, when it's gone year-round, I mean, we're in a totally different climate. Like, goodbye to snow and ice in Canada. We'll have to learn how to farm again. We'll have to start planting. We're already seeing these shifts. Even with the amount of ice that's there, we're seeing these shifts. We had a massive heat wave in March. The winter, it was warm until about mid-December, then it got cold. It was cold in January and February, but nothing like normal. And then March, we had our heat wave. So our winter is almost gone. I mean, winter's gone in terms of snow and ice in Toronto. It's just moving further north, and it's moving quickly. So what's surprising is, I have to deal, with my work, I have to deal with deniers, I have to deal with, but I also deal with climate scientists. And a lot of the scientists are too specialized. Like the whole academic model is to focus in very much detail on one particular area. You're the ice guy, you're the permafrost guy. It's very compartmentalized, and there's not enough communication. So it's amazing to me that I talk to people all the time in these compartmentalized areas, and they're just not seeing the big picture. In fact, recently, one of the glaciologists told me I was absolutely nuts. There's no way the sea ice would be gone in 2050. I bet him $100. I said, no, let's have a bet on this. He wouldn't take me up on it. I've got loads of, all the data is open source. Anybody can go to this data. And there's no explanation for somebody to deny this. The only explanation is that they want to deny it. It's an emotional thing. Maybe they're worried about the implications. But the data is all out there. If you take the time and look at some of the data, then it's very clear to anybody and everybody. And just look outside of what's happening. I started a blog last week with the Sierra Club of Canada. I'll be doing it every week or so. I just sent them a second article. Rabble picked up on it. It's on their homepage now. So you know, it's just like we're in an Orwellian world, I think, as Elizabeth May said.
Yeah.
Not just in climate change, but in many other issues too. But I think it started with climate change because you know, why is climate change such a difficult subject for people to get their heads around? Because everybody knows something about weather. Right? We experience weather every day, rain and snow and wind and sun and different temperatures, right? So everybody knows about weather somewhat. So therefore they make the extrapolation that they know about climate too. You know, average weather. If you know about weather, why don't you know about average weather? So everybody has an opinion. And the more highly educated people are in other disciplines, the stronger their opinions are. And they have these fixed opinions, and they don't listen to people that tell them unless they have, like, there's a bit of a hierarchy going on here. Like, it's a big, but we got to get our head around this, and everybody will. I'm not worried about people becoming aware of this, right? It's going to happen, right? There's no choice. The weather and the climate is dictating that. What I'm concerned about is that it takes too long, and we pass these tipping points. You know, and if we pass a tipping point, it's not like we can, you know, tipping point would be going from where we are now, average temperature on the planet maybe 15 degrees, to average temperature maybe 21 degrees Celsius, and changing to that different state in a decade or so. And we see this in the paleo records. This has happened before in the past. So once we reach that higher state, there's no going back. I mean, we can remove all the emissions, we can do all kinds of stuff, but we're not going to go back because there's hysteresis. So we'll be stuck there for thousands of years. Okay, and you know, the greenhouse gases are sufficient to you know, to nullify the natural orbital cycles. So, you know, normally, according to the orbit of the Earth around the Sun, we should be going cooling and eventually end this warm period, and that'll be completely canceled out. I mean, methane is a big worry because methane levels are sharply rising in the Arctic. The Russians measured huge plumes, a kilometer in diameter or more. It was reported in the Independent back in December of last year. You know, these plumes were an enormous increase in methane from a couple of years earlier. They were 10 meters in diameter. Now they're over a kilometer, many of these plumes. Methane levels are being detected higher at various places on both sides of the Arctic. Also, the satellite data is showing huge increases in methane. And methane, it'll warm the planet. It warms greater than 100 times faster on a short time scale. You know, you hear 21 times, 25 times. That's averaged over 100 years. No, it's a lot more potent than that. So I actually joined, I was so concerned back in December of last year, I joined the Arctic Methane Emergency Group, which is AMEG for short. You can Google it. It's a bunch of people, and, you know, scientists, there's a movie maker, there's a medical doctor from BC, a whole bunch of different people who are very concerned. And I can't keep up with all their emails. It's just a storm of emails, but I try. And Peter Wadhams is a name that you'll see. He's been in the media a lot. I mean, the BBC is covering this story.